questions based on spring. पहले तो स्प्रिंग के लिए फॉर्मूला था F इज इक्वल टू के एक्स माइनस के एक्स. ऑफ कोर्स minus kx was force applied by the spring, restoring force, and the force which you are supposed to apply, that is plus kx. And energy stored in a spring which is compressed by distance x is given by half kx square. And sometimes spring may be already compressed and you may have to increase the compression further. So if x1 was initial compression and you have to push it to a new compression x2, then work done again, work energy theorem equal to change in energy half k x2 square minus half k x1 square. Half k x1 square was work done already, and new work done required is new energy minus what was already stored. Just find the difference. In case of oscillatory motion, SHM, when spring is at its equilibrium position, potential energy stored is 0 and all the energy would change into kinetic as you release it from a distance x equal to amplitude. It starts oscillating on a frictionless surface. Here potential energy is maximum, kinetic is 0, and at the mean position no energy is stored in the spring, all the energy changes to kinetic, half mv square. But total energy would always remain same. That means along with displacement, both positive and negative, kinetic energy would change, potential energy would change, but total energy remains constant. So these two graphs you already had in your chapter simple harmonic motion. So now we have a question. A block of mass m lying on a smooth horizontal surface attached to a spring of spring constant k. At the other end, the block was initially at rest in equilibrium position. The other end is connected to a rigid wall and a force F is applied, constant force, and the block would become static at a point where applied force is balanced by equal restoring force kx and released. What is the maximum speed acquired by the block? So maximum speed would be when whole of potential energy of the spring changes back to kinetic. So first of all, what is the energy stored in the spring? So what is the extension produced in the spring? F is equal to restoring force of the spring. F is equal to kx, so x equal to F by k. So at that moment, energy stored in the spring is half kx square. This energy is going to change into kinetic equal to half mv square, half cancels, solve for v. Simple. Another question based on spring. A body of mass 1 kg falls freely from a height of 100 meter on a platform of mass 3 kg mounted on a spring this way. Platform also has a mass 3 kg and object has a mass of 1 kg. The body sticks to the platform and the spring's maximum compression is found to be x. What is the value of x? If g equals 10 meter per second square. Close to means you have to mingle with calculation. You can temper the calculation. You can use approximations. Okay. First of all, this mass is going to reach the platform. But at this moment, velocity is not 0. It has got some kinetic energy. And it would press the spring further by some distance, x. At this moment, when spring is maximum compressed, where the system is about to return back, velocity becomes zero, kinetic energy becomes zero. So all the potential energy lost by two objects. This 1 kg mass has lost a height equal to 100 plus x more, whereas platform has also lost some height x. So the two have lost some potential energy, gravitational potential energy. That energy would get stored in the spring now. Is it clear? Potential energy lost by 1 kg mass, potential energy lost by platform is stored as potential energy of the spring, because finally velocity is again zero, no kinetic energy is left. Okay, so loss of potential energy of the body, how much? M G, how much H? 100 plus X. And loss of potential energy by the platform, 3 kg into G into X equal to energy stored in the spring, half k x square. M 1 kg, G 10, loss of height 100 plus X. Spring, sorry, second mass, platform, 3 kg, G 10, loss of height X only. Total potential energy, gravitational potential energy lost, equal to energy stored in the spring, half k x square. Okay, this is 10 into 100, that is 1000, plus 10 into x, here 40x, 30x, 30x plus 10x, 40x. Any doubt? Half k is 1.25 into 10 power 6, 1.25 10 power 6 into x square, point removed 100, 25 into 5 is 125, 25 into 400. So denominator 8 in 10 power 6, 8 I am taking to the other side, 8000, 320, and on right hand side 5 in 10 power 6, 5 may be cancelled, 5 into 64 320, 5 into 1600 8000. So you have got a quadratic 10 power 6 x square minus 64x minus 1600. So don't get afraid of it. We have a simpler solution. Discriminator method. X equal to minus b, that is plus 64, plus minus b square minus 4ac, but a is negative, that is plus 4ac. 1600 into 4, 6400 into 10 power 6, divide by 2a. Any doubt up to here? अब सोचने की बात ये है कि 6400 into 10 power 6 के सामने 64 square की कोई औकात है? It is comparison between Reliance and a beggar. Reliance and a beggar. No comparison. So can we leave this term? This term can be left. Root of 64, root of 100, 10, root of 10 power 6. So how much? 8, root of 64, 8, 10 power 3 and 10 power 1, 10 power 4. Again a comparison between Reliance and a beggar. You can leave the beggar, no problem. So 4, 10 power 4, 10 power 6, 10 power minus 2, 10 power minus 2 is 10 power minus 2 meter is 1 centimeter. 10 power minus 2 meter is 1 centimeter. So we have got basically 4 centimeter without any calculation, because question was close to, so we have managed close to.